Welcome to Ganitika.com. This is a website for mathematics lovers, learners, and leaders. In this video, you will be seeing how you are getting this formula for the three algebraic identities a plus b whole square, a minus b whole square, and a square minus b square. Before going into the algebraic identities, you need to know how to multiply two brackets. So if I have two things in each of the brackets, say I have a square and a circle multiplied by a star and maybe a cloud. I'm going to multiply these four things. So if I want to multiply these two brackets, what I will do is I will multiply these two first, which will give me this and this. And then I will multiply this with this, and be careful that this has a plus and this has a plus before that, and you have to multiply along with the sign. So plus square and plus cloud will be a plus square times cloud. And the next thing is you will multiply these two. So again plus and plus will give you plus, and it's a circle and a star. Now the next multiplication is between these two, and again plus and plus will give you plus and a circle and a cloud. So this is how you multiply two brackets. If both the brackets are the same, so if I have the same things within the two brackets, and if I want to multiply them, I can call this as this bracket the whole square. So this is what we are going to actually do in this video, how to multiply, how to find the square of a plus b and a minus b, and then how to find a square minus b square. Now what is a plus b whole square, which is a plus b multiplied by a plus b, as I just explained. Now you need to multiply the a and a, which will give you a square. A times a is a square. And then a times b is ab, which is a is plus and b is plus, therefore plus ab. And then b times a is plus ba, there is a plus before b and plus before a, therefore plus ba. And then plus b times plus b is plus b square. And then the next thing is you can see that there is one ab and another ba. We can write the a square and b square as it is, but we can change the BA to AB to match the other AB. So I have a AB here, I have AB here, so that I can combine them together and write them as 2AB. Therefore, I finally get a plus b the whole square to be a square plus 2AB plus b square. So this will be the identity. A plus b the whole square is equal to a square plus 2AB plus b square. Now let's see what is a minus b the whole square. You can write a minus b the whole square as a minus b multiplied by a minus b. As usual, you multiply term by term. A times a is a square, both are plus, therefore plus a square. Now we have a minus because we have a plus a and a minus b, therefore we have minus ab. Next is there is a minus b and plus a, therefore we have minus ba, and we have both minus and minus b, therefore it is plus b square. Now I will write the a square minus b plus b square as it is, and we will see what is happening in between them. So as usual, the ba can be interchanged as ab because a and a times b is the same as b times a, and you have minus ab, which becomes minus 2ab. So the formula for a minus b the whole square now becomes a square minus 2ab plus b square, and that is the identity you have here. What mistake you will usually do when you are doing a plus b whole square and a minus b whole square, and which you are not supposed to do, is this. A plus b the whole square is not equal to a square plus b square, but it is equal to a square plus 2ab plus b square. Remember this, don't forget. And the same way, a minus b the whole square is not equal to a square minus b square, but it is equal to a square minus 2ab plus b square. Remember this carefully. Never forget this. Next, we are going to see what is a plus b multiplied by a minus b. So as usual, you start multiplying term by term. A times a is a square, both are plus. And a and b, plus a and minus b gives me minus ab. The next is plus a and plus b, both are plus, therefore it is plus ba. And next is plus b minus b gives me minus b square. Now as usual, I will write the a square and b square a square minus b square. I'll write it as it is. And let's see what's happening between minus ab and plus b. As usual, ba can be written as ab. Now it is minus ab plus ab, and they get cancelled. And they go off. A square minus b square is what you finally get. Therefore, a plus b times a minus b is nothing but a square minus b square. And these are the three identities you just learned. Hope you understood and hope you enjoyed. Bye-bye.
What will be the algebraic expression that represents the following information? A box contains p chocolates. There are 5 such boxes and there are extra 3 chocolates. If you have done the activity 1, you would be able to do this. Okay. Now let's see what's the algebraic expression for this particular information. The answer is yes, of course you're right. 5 times p plus 3. It is 5 boxes of p chocolates each plus extra 3 chocolates. Okay, let's try one more. What does the expression 3 times s plus 5 mean? Answer. This means that there are 3 boxes of s chocolates each with 5 extra chocolates. Good, great. So what is an algebraic expression? Algebraic expression is a phrase. You know what a phrase is? Phrase is a statement, a sentence in English. But this is phrase in mathematics that describes a situation which has some unknown information. You have some unknown information, but it's a statement, it's a sentence, it has some meaning. This unknown information is represented by letters like P and S that we used just now. The activity 1 described the situation in which some unknown numbers of chocolates have been placed in certain known number of boxes, which means we had P number of chocolates placed in 5 boxes, right? And we have S number of chocolates placed in 3 boxes. So we know the number of boxes, but we don't know the number of chocolates. Therefore, we assigned the letters P and S to the number of chocolates, but the boxes were known, so we had the numbers 3 and 5 for them. What is unknown? The unknown number of chocolates, which here in this case, the unknown is the number of chocolates, is called a variable. And the known numbers are called constants. In this cases, boxes and the extra chocolates, they are called constants. The number of boxes in the chocolates that is attached to the variable is called coefficient. So in the first case, we had 3x plus 5, or we had 5x plus 3. The 5 is a coefficient. In the second case, we had 3s plus 5. The 3 is the coefficient. Therefore, the number attached to the variable, attached to the unknown letter is called coefficient. Fine? Now, let's check your understanding. Write down the variable, constants, and coefficients in each expression listed below. So you know what is variable, you know what is a constant, and you know what the coefficient is, right? Now, let's try doing this. So in the first case, what's the variable? 4 times y plus 6. The variable is the letter that's used here, therefore the variable is y. The constant is this one, the 6. And the coefficient is the number which is attached to the unknown, which is 4 here. Okay. In this case, 5 plus 2 times t. The t is the variable. The constant is the number, extra number here, which is 5. And the coefficient is the number attached to the unknown, which is. Now, finish off with the rest of the questions. Sure, you should have done this correctly. Let's check your answers now. In this case, the variable is r, and the constant is 1, and the coefficient is 3. The constant is here, the variable is here, and the coefficient is here. Okay, here 3 divided by x plus 4. This, you can see the difference here. This is division. The unknown is in the denominator, but still the variable is x. The letter, the unknown, is x here. The constant is that extra thing here, which is 4, and the coefficient attached to the x is 3. Therefore, 3 is the coefficient. This is a bit complicated expression, but we will see this later in the further lessons. Okay. And in this case, we can see that this is just 3 times p, which means that there is no extra chocolates, right? The variable is the unknown letter, which is the letter which is unknown, and there is no constant. The constant is 0 because plus 0 is here, and the coefficient is 3. Good. Variable here is a. The constant is 7. No, the constant is minus 7 because there is a minus here. In these cases, it was plus 4, it was plus 1, it was plus 5, etc. Okay. And in this case, the coefficient is minus, sorry, plus 2. Okay. Coefficient is not t, it's a number attached to t. Hope you identified that error when you were working on this. Coefficient is the number attached to the variable, which is 5 here. Remember, the constant goes with the sign. If there is positive, you don't need to write the positive sign. You just have to say 4. But if there is a negative sign, you need to say minus 7. So what is the use of all these things? Let's consider the situation of number of students in grade 6 in your school. Okay, number of students in grade 6. There are some students in your class. We don't know how many of them are there. Let's see. The school decides that in every class there should be exactly 15 students. Okay, but there can be any number of sections. They don't bother about number of sections, but in each class there should be only 15 students. There are 3 students who are admitted in grade 6, but they come under special needs. Therefore, they are not in this group of 15 students. They are not in these classes sections, but they are a separate group altogether. So 3 students are separate, extra in the language that we have been using. Extra 3 students. So it is plus 3 students. Okay, remember that. So we have 3 students as a separate group. Can we make this into an algebraic expression? Yes, of course. Number of students 15 times number of sections plus 3 would be the total number of students in grade 6. Fine. So how many ever sections you have? Each section has 15 students. So you multiply them and then add the remaining 3 groups here. The 3 member group here, so that you'll get the total number of grade 6 students. Number of sections, if you call it as n, then the expression becomes 15 times n plus 3, which you have already seen. Now, how do we use this? We can see how many students will be admitted if we have 1 section, 2 sections, or 3 sections or more. Okay, try to do them. Try to get the number of students for each case. When you have 1 section, 2 section, and 3 section, if there was 1 section, then the total number of students would be 15 times 1 section of 15 students plus the 3 extra students, which would be 18 students total. So 1 section plus 3 students, 15 plus 3 would be 18. Now 2 sections, 1 section has 15 students, there are 2 sections, therefore 15 times 2, and there is a group of 3 students extra, therefore 33 students, which means 1 section of 15 students, another section of 15 students, and 3 extra students altogether will make 33 students. 3 sections, it's easy now. 3 sections of 50 students each plus 3 would be 48, and so on. You can continue doing this for how many ever sections you need or how many ever sections you have. You can find the total number of students, and this is how it's used. In an expression, we can substitute any value for the variable and calculate the total value of the expression. That's what we just did. Substituted n is equal to 1, 2, and 3 in this case, right? So that's what we did. We substituted. Substitution means we put in the value for the variable. That is, we plug in the number into the letters. Find the value of the expression 2 times a plus 6 for each of these values. Okay, let's see how to do this. A equal to 1, what happens? There is an example here and you are supposed to do the rest of it. A is equal to 1, you bring the a here and replace it with 1, and it is 2 times 1 plus 6, 2 plus 6 is 8. So when a equal to 1, the expression 2a plus 6 is 8. And try the other values yourself. How to write an algebraic expression? The expression we saw so far were written like 3 times p plus 5, for example, right? You don't have to actually write 3 times p all the time. You can just take away the multiplication symbol and you can move the p closer to the coefficient. 3 is the coefficient, remember? So that you can just write it as 3p plus 5. Instead of 3 times p plus 5, just write it as 3p plus 5. And this is how it's always 3x plus 5, 3 cubed plus 5, and so on. If you see an expression 5t plus 2, what does it mean? It's 5 multiplied by t plus 2. Add it to 2. That's what it means. 5t means 5 is multiplied by t plus 2 is added to it. Now, how do you combine expressions? Say, for example, there are two students in grade 6, Alice and John. Alice is buying two boxes of chocolate, candies actually, and she has four extra candies. And John has three boxes of candies and he has three extra candies. So how will you write them into expressions? Of course you can. If I have C as number of candies in each box, we have for Lice 2C plus 4 and for John 3C plus 3. And you should have been familiar with this by now, right? C is the number of candies in each box. Now, what happens if they want to carry them together? So totally we have five chocolate candy boxes, sorry, five candy boxes. Therefore, we have five C candies inside these boxes, and we have seven extra candies, right? So the total would be 5C plus 7. So this is 2C plus 4 from Alice plus 3C plus 3 from John. Therefore, you add up together 2C plus 3C is 5C and 4 plus 3 is 7. Okay, and that's how you combine two expressions. Just add the expressions which has the letters together and add the constants together. Fine, this is not going to be difficult at all. So if you have 5c plus 3 and 4c plus 2, add these two expressions. You first add 5c and 4c together and make it as 9c. And then add 3 and 2, which is here. 3 and 2 will become 5. Therefore, 5c plus 4c becomes 9c. And 3 plus 2 becomes 5. And that's all. Have a great day. Bye.
In this video, you will be learning about why linear equations are called linear. And a linear equation means it looks like 2x plus 1, 3x plus 5, 4x minus 2, 2 minus 8x or something like that with one x value, one x variable in there. So let's consider the expression 2x plus 1 and let's say that is equal to y. Let's call 2x plus 1 as y. So y is equal to 2x plus 1. And what we are going to do is we are going to plug in different values for x and then going to find out what the value for 2x plus 1, which is actually equal to y, would be. So let's make a chart on this process. So what are the values of x we would like to take? We can say, for example, we can take any values like minus 100 or plus 100 or 1000 or 10,000, whatever. But for simplicity's sake, let's take values for x from -1, -2, -3, 0, 1, and 2, 1, 3. Let's just keep it to that set of values for x. And once you start plugging in the values one by one to 2x plus 1, then the y values, which is 2x plus 1 value, will start giving different values. Okay, so let's say for an example, let x is equal to negative. Let's say x is equal to -1, and when you plug in that -1 into this place, we get 2 times -1 plus 1, which is -2 plus 1, which is -1. So you get the value of y. Y is nothing but 2x plus 1. So the value for 2x plus 1, which is y, will be -1. I'm going to give you another example of this. So let's say x is equal to 3. So plug in the value of 3 into the place of x. So 2 times 3 is 6 and plus 1 is already there in the expression. So 6 plus 1 is 7. So when x is equal to 3, y would be equal to 7. And when x is equal to -1, y is equal to -1 and so on. So I just used these two values for x. And you need to go on doing for all these things and make a nice table. Let's see how the table would look like. So let's say if the x values would be -3, -2, -1, 0, 1, 2, 3. This is what we decided to use x value as. And then for each of these values, we are going to find its corresponding y values. So for -3, the value for y, which is 2x plus 1, y is nothing but 2x plus 1, right? So for each value of x, you will get different values of 2x plus 1, which is y. So now we have one value of x, one value of y, and there are 7 of them, right? So what we are going to do now is going to collect them as a pair, which this pair is called an ordered pair. Those who have done coordinate geometry would know what this means. Ordered pair, and this is used to plot points on coordinate axis, and that's what exactly we are going to do now. Now let's make another, we have made another row collecting the x and y values in ordered pair form. That is x in the first part and y in the second part, and so on. For each of these x and y values, we make them into a pair. And then we collect and write them as one of the rows in the table. Now let's see what we are going to do with this ordered pairs. So these can, as I said, these can be plotted on a coordinate axis. How? The x values will be taken on the x-axis and y values will be taken on the y-axis. Okay, now we are going to plot the points. The points had x comma y. The x values are plotted on the x-axis and the y values are plotted on the y-axis. And the x values are going to take the values from -3 to +3, and we are not going to bother about this part. So we are going to plot the points which is like -3 comma -5. We have them on our data set. So this is our data set and we are going to plot these points. Okay, so the first point is -3 comma -5, which is here. The next point is -2 comma -3, which is here. So -3 is y and -2 is x. Then it is -1 -1 if you are used with negative. This is 0 comma 1, which is here, this point. And then we have 1 comma 3, which is here, and 2 comma 5 and 3 comma 7. 3 on the x and 7 on the y, and you can plot them. Now what happens when you join these points? Let's see. Wow. And here is a line, and that is the reason the set of points that are given by this x comma y, where y is 2x plus 1, gives you a linear equation. Now it's time for you to check your understanding. We did it for 2x plus 1. Now you are going to do it for 3x plus 2. As before, equate 3x plus 2 as y, make it as y, and this is an equation, and of course we know that this is going to be a linear equation. At the moment, you will call this as an equation. Later, when you grow up into grade 11 or grade 12 classes, you will call this as with a different name. So at the moment, let's say an equation, linear equation is y equal to 3x plus 2. Consider the x values from -3 to 3. That is, as before, we had -3, -2, -1, 0, 1, 2, 3 for x values. Use the same set of values for x and then input them, that is, plug them in into 3x plus 2 and find the value for y for each value of x, as we did for 2x plus 1, and complete the table and collect all x's and y's, and then use these pairs, ordered pairs x comma y, to plot a graph and then join the points and see if you're getting a line or not. And if you have done this, you should be able to proceed further. Pause this video for a moment, go back, finish your work, and then come back and see whether your answer is correct or wrong. This is going to be a line because it's a linear equation. We have already understood that a linear equation should give you a line on the graph. But what you need to know now is whether your answers are correct. Like these, do you have these as your ordered pairs in your table? -3, -7, -2, -4, -1, -1, 0, 2, 1, 5, 2, 8, and 3, 11. And if you had them on your table and if you plotted them correctly on the graph, then you would have definitely got a line, which means that 3x plus 2 is again a linear equation. So what we have observed is, what is a linear equation? A linear equation will always have an equation with one variable. So the equations of the form 2x plus 1, 3x plus 2 is what we saw, and you can have variety of such equations, 5x minus 3 or 5 minus 2x. All of them, you can see that there is only one variable involved in this, and this variable gives you in terms another value for which is y. So y, which is equal to the expression itself, has one variable in it. So equations with one variable is called a linear equations. Basically, that's what you need to understand. Hello, welcome back to linear equations. In this video, you'll be learning about how we can form linear equations using some real-life application problems. So let's see a typical problem here. Linnea wants to join a swimming course. She approaches a nearby swimming school and finds the following rates. That is, she has to deposit $50, which is not refundable, so it's just paid and it's a deposit. But after that, for every hour, she has to pay $15, which means for 2 hours, she would have paid $30 with the $50 that she has already paid. So now if she takes 2 hours of class, she would have already paid $80. So, and so on. So this is the basic question. So how can we frame a linear equation from this problem? Okay. So let's try to find the total cost of her swimming classes for each hour she goes. Like if she goes for 1 hour, how much? If she goes for 2 hours, how much? And so on. Okay. So for that, let's make a table. The table consists of hours in one row and total cost in the other row. So if she's going for 1 hour, the total cost would be 50 plus 15, because 50 is the deposit and 15 is the hourly payment. So 50 plus 1 hour payment, which is 15, will give her the cost of $65. If she went for 2 hours, she would have paid, as I just said, 50 plus $30, which is $80. And if she went for 3 hours, she would have paid 50 as a deposit, but 3 times 15 is 45, so $95. And if she goes for 6 hours, how do you do this? How can you find it out, like without going one by one? So let's see what happens here. The 15 here came from, okay, 15, 30 and 45, all these numbers came from the one from the top, that is from the number of hours we have. The 1 times 15 gives you 15, and 30 comes from 15 times 2, which is number of hours is 2, therefore 15 times 2 gives you 30, and the 45 comes from 15 times the 3 hours. Now, what will you do if you are asked to find how much does it cost for 6 hours? So it's very simple. 15 times what? It's the number of hours that you need to multiply the 15 by, which is 15 times 6, which gives you 90. And then you need to add this 90 with the original deposit 50. So the cost is now $140. Now, you have to pause this video for a moment and then find out what's the cost if she has to go for 7 hours. So I think you must have done the calculation for 7 hours now. So let's see if you have done this correctly. For 1 hour it is 65, 80, 95, and for 6 it is 140, and for 7 it should be $155. I hope you were able to do that. Now let's go further and see what happens. See, I want to find how much does it cost if she took 100 hours or 110 hours, for example. So you can't keep doing the same thing one after the other, right? So let's see how we can use linear equations for this. So for 100 hours, what you would have done is 50 plus 15 times 100, which would be 50 plus 1,500, which is $1,550. That would be her cost for if she went for 100 hours. And for 110 hours, it would be 50, the original deposit, plus hourly payment, which is 50, times the number of hours, which is 110. Therefore, this cost would be 1,700, right? Now let's say it goes on, like if you can't keep adding on a table of values like this. So let's see how we can make a linear equation from this, and how is it going to help us. So it's the linear equation that we are going to make is going to help us do the problem without drawing such big tables. Fine. So let's see, she is going for h number of hours. That is, we do not know how many number of hours she is going to swim, some h number of hours. So how will you find the cost for this h number of hours? So what you have been doing is 50, the original deposit, plus 15 times the number of hours, right? So the question mark has to be replaced by any number of hours that she has gone for her swimming class. Now we have h as the number of hours. Therefore, it is 50 plus 15 times h. And what does this give you? This gives you the total cost of her swimming class if she goes for h number of hours. So this will be the equation of the cost for her swimming class, with h as the number of hours, and h is the variable here. You keep changing the h value, 1, 2, 3, 4, 5, anything, and then you can find the total cost that she should have been paying for her swimming class. So the equation now is C, which is the cost, is equal to 50 plus 15h. h is the number of. So what is the advantage of using linear equation for such problems? So the problem now comes down to a simple linear equation, C equal to 50 plus 15h. And if you want to find the cost for different hours, you can just substitute the value of h in this equation and you can find the cost for that. For example, if h is 1, you get 65. If h is 2, which is the number of hours is 2, you get 80. If it is 4, you get 110. So this we have already done this in the table in the beginning of this video. If you have forgotten, you have to pause this and go back and check the numbers again. So for example, let me see. If I want to find, say for 20 hours, she's going for 20 hours. So all that I need to do is put this h value as 20, multiply this by 15, and then add it to 50 to get the cost that I want. So the cost is now very simple, which is $315. So it's very simple. I don't need any table anymore. So that is the advantage of making the linear equation. In later stages, you will also see how you can use this for drawing graphs, and from different graphs you can interpret so many other data. So this is going to be very, very helpful for you in future. Do you always need a story to make an equation? Definitely not. You can make an equation just by looking at the set of numbers you have, 65, 80, 95, and 110, and so on. These are the numbers that you found for the cost, right? So this is corresponding to each hour that you heard. 1 hour, 2 hours, 3 hours, and 4 hours. Now I'm not going to call this as hours because we are not going to have any story. There is no linear, there is no swimming classes, there are no costs. So it is just a number, 65, 80, 95, 110. They are called sequence of numbers. They are given to you. Now the first number, so the one here, I will call this as the first number is 65. The second number is 80, the third number is 95, fourth number is 110. So I can find easily what is fifth number, and you can find it. You know that you are going to get the number by adding 15 to the previous number. So all that you need to do is add 15 to this, and then you will get the new number. And you know what is going to be the sixth number. Add 15 to this, you will get the sixth number. And so on. You know how to get this. But can you just go on to find, if I'm asking you to find what is the 100th number, it's going to be a very tedious job. So this is where the linear equation comes handy for us. So you know you're going to add 15 to get the next number. So you go back and start with the first one. What did you add to this 15? What did you add this 15 to get this 65? It's very simple, right? It's a very, very, very simple arithmetic question. So you should have got a 50 in the first place, so that you would have added 15 to it to get the 65. So to get 65, you added 115 to this 50. In order to get 80, you should have added another 15 to 65 so that you got 80. And then for 95, you would have added another 15 to get 95. So what happens? What is actually happening if you can see the pattern here? For getting 65, first number, you added 150. For the second number, which is 80, you added 215 to 50. For third number, you added 3 15s to 50, and so on. So if you want to say what is the number for 6, you would have added 6 15s to the 50 original number to get 140. You can check this calculation, it's going to be correct. So what happened, you start with the 15 here, keep adding 50. How many number of times? The same number of times you have the numbers here. So if you want to find the 100th number, you are going to go on for this 15, adding the 15s. How many times? 100 times, right? So 100 times 15, but you started with 50, therefore the original 50 is going to be added. So that will be the answer for the 100th position, correct? So if I can make this 100, 200, 300 as x, then I'm having 50 plus 15x. So this is the linear equation for this set of numbers. So I can write it as a proper linear equation. Y equal to 50 plus 15x. That is what represents, that equation represents the number given, which is 65, 80, 95, 110 and so on. You can check this by substituting the values of x as 1, 2, 3, 4, etc. And then you'll get all these numbers one by one. So this is how linear equation is very, very useful. You can frame the linear equation from a given story, or you can also frame a linear equation just by looking at a sequence of numbers. Sequence of numbers means they are formed with some rule. In this case, the numbers are formed by adding 15 to the original number. So there is a rule to make a sequence. So if you are given such a sequence of numbers, you can easily make the linear equation from them. So here are some problems for you. Again, pause the video and see if you can make the linear equations for all these three sequences of numbers. So I hope you have paused the video and you're back. Now you can check your answers. So this is, the first sequence is 3, 5, 7, 9. And all that you need to do is you need to write these numbers. You don't have to write them, but I'm just writing them so that I know what is going to come next. So what I'm thinking now is what is being added to get the next number. It's a very easy, simple guess. It is 2. Therefore, the next number would be 11. And just to make it sure, it will be 13 and so on. This is your sequence. So if you add a couple of numbers after that, you get the idea of what the sequence looks like. Now all that you need to do is what would be the number that came from. So you need to subtract the number 3 and therefore the number is 1. So you add 1 to the number that is being added is 2. Therefore you add 1 to 1. So 1 plus 2 times 1. And then you need to add 2 2's to 1. So 1 plus 2 times 2 to get the second number. And then to 1, this one, you need to add 3 times 2 to get the third number and so on. So what you need to do is you are adding 2 each time you increase your number of numbers. So you stay with 1 plus 2 times the number that you want to add. You want to get the number of terms that you want to get is x. Therefore, the answer is 2x. We don't write 2 times x, so we write 1 plus 2x is the equation, and you always put the y here so that it gives you the actual number. So y is equal to 1 plus 2x. So if you substitute, for example, x is equal to 5, then you are getting 1 plus 2 times 5, which is 11, and this is your fifth number. 1, 2, 3, 4, 5. Fifth number is 11, and when your x is 5, which is the fifth number, you get 11 as your y value, which is the correct answer. I hope you got this correct. Let's see what happens here. Again, you need to check what you're adding to get the next number. So it is going to be 30. You're adding 5. Therefore, 30, 35, 40, and so on. It goes like this. And what should be your original number then? You have to add 5 to it so that you get 5, right? So the original number should have been a 0 because you add 0 to 5 to get 5. So there is nothing here. You didn't do anything. You started with the first number as 5 directly, and you kept adding 5 to it. So what happens here? 0 is the original number, and you keep adding 5 how many number of times you want, right? Whatever number of times you want, you keep adding 5 to the original number 0. So this is 0 plus 5x, correct, which is y. So the original number is 0. You keep adding 5 how many number of times you want. Say if you want 1, 2, 3, 4, 5, fifth number, you need to multiply 5 times 5 with adding it to 0. So adding to 0 5 times number of times you have. You want to find the number there. So the answer here is y equal to 0 plus 5x. I hope you got this answer, but this is not correct. We don't write this part. The actual answer that you should have written is y equal to 5x. There is no, it doesn't look like a plus bx because this a is 0, so it looks like y equal to bx in this case. You will learn more about such equations later. So if you got this answer, you are perfect. But if you got this answer, you are halfway through and you have done a good job yet. Let's see what happens here. 100, 90, 80, 70. You are not adding anything to 100 to get the 90. 100, 90, 80, 70 and so on. So we are not going to add anything to get 10 to 90, but you are going to subtract 10 to get 90. So here you are going to subtract 10. So you are going to subtract 10. So you are going to actually subtraction of a number is adding a negative number. So you are adding negative 10, whatever number of times you want, but to what? How would you have got 100? You have to subtract 10 to some number so that you got 100. And you know very well that it should have been 110. So from 110, you need to add negative 10 times how many number of times you want. So this will be your y. So instead of positive, now it is negative. That's it. Its subtraction is adding negative numbers. This is what you need to know here. So the actual answer should be y equal to 110 minus 10x. So it is, if you have written 110 plus minus 10x, that's perfect. That's okay. But if you want to be very, very specific and truly mathematic, then you should have written this plus and minus together as minus 10x. So this is supposed to be your final answer. I hope you understood this. Bye-bye.
In this video, we are going to see how to solve certain equations. Let's take for example 3 times x plus 2 equal to 5. Actually, in this video, we are going to see some higher level equations and see how they can be solved. Simple equations like x minus 2 equal to 6 or 3 times 3x plus 2 equal to 5. These equations we have already done before in the same section. Now we are going to move forward to see how to solve equations with a little higher level of difficulty. So in this case, if we are going to take this equation as 3 times x plus 2 equal to 5, how are we going to solve this? There are two ways of doing this. We can actually open the bracket 3x and 3 times 2 is 6. So 3x plus 6 is equal to 5, and then we can make this equation look like this equation, and then we can balance the equation on both the sides, like you have to subtract minus 6 on both the sides to eliminate this 6. So we'll have 3x on this side and we'll have 5 minus 6 is minus 1. So x is equal to negative 1 over 3. This is one way of solving this equation. The other way is we have 3 times x plus 2 equal to 5. So this multiplication can be removed, like we can just divide by 3 on both the sides first so that this 3 gets off. Then we have x plus 2 is equal to 5 over 3, and then we can subtract minus 2 on both the sides so that this goes off, and we have x is equal to 5 minus 6 over 3, which is negative 1 over 3, and it's the same answer as before. So whichever way is convenient to you, you can use. Next, let's see another example. 3 times x plus 2, but we are going to add some more. 2 times x plus 3 and equal to 6. So we have two terms on the left hand side, two bigger terms. So in this case, you cannot divide by 3 or divide by 2 because there is a plus sign here. So you cannot take these two numbers out of the place now. So the only way you can do is open the bracket. So it is 3x plus 6 on this, and then 2x plus 2x plus 6. Be careful about the positive negative sign. We have all positive here, equal to 6. So we can add the like terms 5x, and I would actually cancel one of these 6's, but I can actually add these two 6's and make it 12 on this side and keep the 6 on the other side the same. So we are now reducing this equation to something like ax plus b equal to c form. So we know this, how to do this. We need to eliminate this b, so subtract b on both sides, and then we have to take out this a by dividing by a on both the sides. So this is the method we have already followed. So we'll use the same method. So we want to get rid of this 12, so subtract 12 on both the sides. So we'll have 5x is equal to negative 6. So 6 minus 12 is negative 6, and these two get cancelled. So then divide by 5 on both the sides. So we'll have x is equal to negative 6 over 5. So this is your answer for this particular equation. Let's move on and see another equation where we have 2x plus 5 on one side, and on the other side also we have an expression with x, say 6x minus 3. So how do we solve this? On both the sides we have x terms. So basically we need to find x is equal to what, right? So we need to have x on your left hand side and all the numbers on your right hand side. So we need to take this 6x to this side. So what we need to do is removing plus 6x will be subtracting 6x from this side. So when you subtract 6x from this side, you have to subtract 6x from this side. So this becomes 2x minus 6x will be negative 4x, and there is nothing here, so plus 4. These two get cancelled, and you have minus 3 on this side, and you have equal to in between. So just you remove this 6x so that you get it on the left hand side in the opposite sign. So we have now reduced this to minus 4x plus 5 equal to minus 3. And how to proceed? We have to subtract minus 5 on both the sides, so that you will have negative 4x on this side alone. These two go off, and then you will have negative 8. So x is equal to, so we divide by negative 4 on both the sides, so that the negative 4 goes off, and then we have x is equal to 2. So basically speaking, if you have x term on the right hand side, see that it is taken to the left hand side using the opposite operation. Now let's make it little more complicated. We'll have on the left hand side 2 times x plus 5 plus 4 times x minus 1. We have two terms, a little more complicated as we have seen before. But on the right hand side also we'll have a complicated set of terms, say 6x minus 1 and 8x plus 8 times x plus 2, for example. So we have this bracketed terms on both the sides with addition or subtraction, whatever we have. So the basic idea is multiply term by term on both the sides, and first expand the expressions on each of those sides. So 2x plus 10 for the first term plus 4x, and be careful about the positive negative sign. Here it is minus 4, and put the equal to sign because we are done with the left hand side. We are moving on to the right hand side. So 6x here, and 6 times minus 1, careful about the negative sign, minus 6, and plus 8x, 8 times x, and plus 8 times 2 is 16. So this is what we have. On each of these sides, collect the like terms and simplify separately. Okay, so 2x and 4x and 10 and minus 4 on this side, 6x and 8x and minus 6 and plus 16 is what we have on the other side. 2x plus 4x gives you 6x, and 10 minus 4 gives you plus 6. So this is how we simplify on the left hand side, and we keep the equal to sign at the moment, and 6x plus 8x is 14x, minus 6 plus 16 is plus 10, and we have this form which we have already seen. We have x terms on both the sides. So we have already seen that we have to remove the x on the right hand side, bring it to the left hand side. So what we can do is do the opposite of plus 14x, which is minus 14x. So first you bring the x term to one side, on the left hand side is always better, and so we have 6 minus 14x is minus 8x. And remaining things we just write it as it is. Here they get cancelled. That is the idea we did to subtract 14x. And we are simplified to this form where you have an x term plus a number equal to another number, and we know what to do. We just need to subtract so that we get rid of this extra term on the left hand side. So we have negative 8x is equal to 4, and then what we need to do is divide by negative 8 and divide by negative 8 on both sides, so that this cancels, and then therefore we have x is equal to minus 1 over 2. Let's add little more difficulty to the problems. Let's consider some fractional terms like x over 2 plus 3 equal to 2x over 3 minus 4. So we are going to have x terms with fractional coefficients, and we are going to have x terms on both the sides of the equation. So how do we do this? It's the same thing. There is an x term here, there is an x term here. So it's better to bring all the x terms to the left hand side, and for that we always use the opposite of this, which is this is plus 2 over 3x. So you have to subtract 2 over 3x. So subtract 2 over 3x on both the sides and then simplify. So while simplifying, let's keep the term as it is. We'll simplify this later. X over 2 minus 2 over 3x will be here, and then this plus 3 remains as it is. On the other side, this gets cancelled and you will have negative 4. Now we'll do only one step here. Let's forget about what to do with this, but we'll get rid of this minus plus 3. So we have to subtract 3 on both the sides to get rid of this plus 3, and remaining things we will not bother at the moment. We'll keep it as it is. And then on this side we are going to have negative 7 because plus 3 and minus 3 are going to get cancelled. Now let's concentrate on how to simplify this part. This is same as 1 over 3, forget about the x, 1 over 3 minus 2 over 2, 1 over 2 minus 2 over 3. So forgetting about the x, this is same as subtracting two fractions. So we will be taking the LCM, and then we will cross multiply and we will see 3 minus 4, which is negative 1 over 6. This is how we do for normal fractions in numbers. The same way you do it here. You take the LCM as 6, multiplying this by 3 and multiplying this by 3 and multiplying this by 2 and this by 2. This is the way we use addition and subtraction of fractions in numbers. So you do the same thing, whereas here we have 3x and here we have minus 4x is equal to negative 7. So now simplify this. 3x minus 4x is minus 1x. We don't usually write the minus 1 there, so we write minus x over 6 equal to minus 7. So minus x is equal to negative 42. How did we get that? We need to simply multiply this by 6, multiply by 6, because division 6 opposite is multiplication 6. So multiply 6 on both the sides. This cancels. So on the right hand side, minus 7 times 6 is negative 42. So you have negative x on this side and negative 42 on this side. So we are actually doing the opposite of division of 6 as multiplying by 6. Now in order to get rid of, we don't want minus x as our answer, so we need to get rid of this. So you can multiply by a negative 1 on both the sides, which gives you x on this side, and minus 42 times minus 1 is 42. So the answer for this question is x is equal to 42. Let's move on to a little more complicated question. So here we are going to have x plus 3 all over 2 and equal to 2x plus 1 over 3. Here I am not going to have the division for the whole term, but we are going to have 2x as separate and 1 over 3 as a separate term. Now how do we do this? We need to first get rid of this 2. It's always better to get rid of this 2 here because it is whole divided by 2. The whole side is being divided by 2. So division of 2 opposite is multiplication of 2. So you multiply the whole thing on the left hand side by 2. Therefore you have to multiply the whole thing on the right hand side by 2. Not just x terms are not just one of the terms, but you are multiplying the whole thing by 2. So in this case this 2 gets cancelled and x plus 3 is what you have on this side. On this side, be careful, you have to multiply the 2 by both the terms, 4x plus 2 over 3. Now you have on two sides expressions on two sides, and we have x terms on both the sides. So we will concentrate on bringing this 4x to the left hand side by subtracting 4x on both the sides. So this gives you minus 3x plus 3, they cancel here, equal to 2 over 3. Now it is a simple one. So this I am going to do it little faster. Minus 3 on both the sides. So minus 3x is equal to 2 over 3 minus 3, which will give me 2 minus 9 over 3, which is negative 7 over 3. So I am having negative 3x is equal to negative 7 over 3. So the next is opposite of multiplication by negative 3, which is division by negative 3. Division by negative 3. So in this case negative 3 gets cancelled and you will have x is equal to negative 7 over 3. Division by negative 3 is negative, multiplying by negative 1 over 3. So you will get 7 over 9 as the answer for this question. And that is all. We have dealt with all the equations. So basically speaking, all equations should finally be brought to this form, and then once this is brought to this form, you can subtract minus b on this on both the sides, so that you will have ax is equal to c minus b. And then the next step is good to get rid of this a, divide by a on both the sides, so that the a goes off and you are only left with x on this side. Whatever number you are getting on the right side will be the answer for x. And if you have anything multiplied, x plus c or something, you multiply like this. And if you have anything over another term also getting multiplied, you multiply them and collect all the like terms together and make it one x term and one constant, and then equal to a number. Could be a number on the other side, or it could be another expression. So if you have an expression in x plus a number equal to another expression in x plus another number, then bring this expression to this side by subtracting this expression of x on both the sides. In the box, x means not just x, it's an expression. It could be 2x, 3x, 4x, 5x, or half x, or 2 over 3x, whatever it is, it's a term in x. So that term in x should be subtracted on both the sides, so that there is no x term on the right hand side, and this number will be joined together by doing the opposite signs, so that you will have one x term on this side equal to another number on this side, and then you can easily solve this later. So this is a summary of what we did in this video.
Today's concept is how to solve simultaneous equations using substitution method. Simultaneous equations means two linear equations either in the form y equal to mx plus c, or in the form ax plus by plus c equal to 0. So either way, whether the two equations are both in this form or both in this form, or one in this form and one in this form, whatever the forms are, we should be able to solve the equations, and that is what we are going to do in this video. As the beginning, we are going to use both the equations in the form y equal to mx plus c, which means we can, for example, we can say y equal to 2x plus 3 and y equals 3x minus 4, for example. And these are the two equations we are going to consider, and we are going to solve these two linear equations. So what does it mean by solving two linear equations? Like you have two linear equations, they can be like this or this, either whatever way it is, depending upon the equation of the lines. So for example, this could be y equal to m1x plus c1, and this could be y equal to m2x plus c2. And when you solve for these two equations, we are actually finding the point of intersection. This is the solution of these two equations when solved simultaneously, which means we are actually finding the x and y values of the two equations here when they occur simultaneously. So let's start solving them. So let me call this as equation 1 and this as equation 2. So what I'm going to do here is, since we are talking about the point of intersection, at that point both the equations satisfy each other. Therefore the y of this equation can be substituted into the y of this equation, which means the expression for y from the first equation can be replaced in the place of y for the second equation, which means the second equation becomes 2x plus 3 in the place of y, and the right hand side remains the same. So this equation becomes a simple equation in one variable, which can be easily solved like this. So x is equal to 7 will be the answer for x. Now as I said, we are supposed to be finding x and y. We have just found x and we need to find y. To find y, we can either use equation 1 or equation 2, but for simplicity's sake, let's just use equation 1. So in this equation, whichever equation you consider, substitute the value of x that you got in the previous step and simplify and see what you are getting for y. And in this case, we are getting y as 17, which means the point of intersection for this particular question is 7, 17, and the solution is x is equal to 7 and y equal to 17. So all the solutions for two simultaneous equations will be in terms of x is equal to something and y equal to something. So in this case, we have done this solving of simultaneous equation when both of them are in the form of y equal to mx plus. Now we are going to see how to solve simultaneous equations if one is in this form and the other one is in this form.
So let's take an example, y equal to 2x plus 3. The first equation is in the form of mx plus c, and the second equation is in the form of ax plus by plus c is equal to 0. So this is the second equation. So how to solve these two equations? It's the same method, is the same, the idea is the same. The idea is we have to take the expression of y from the first equation and substitute in the place of y in the second equation, and that is all we need to do. So the second equation becomes 2x remains the same, minus 3 also remains the same, but at the place of y we need to bring the expression from y from the first equation and put that into this place. So y becomes 2x plus 3 and the remaining part is the same. So the equation number 2 becomes 2x minus 3 times 2x plus 3 plus 1. So solving this as usual, this is very simple, opening the brackets and simplifying, collecting all the like terms together and solving for x. We get x is equal to minus 2. Now we have got x, we need to find y. Again, as I said, you can either substitute the value of x in either equation number 1 or equation number 2, doesn't matter, but in this case you can see that it is easier to substitute in this equation rather than the second equation, because second equation looks a little bit more complicated than this one, because if you substitute the value of x in this, you directly get the value of y. So it's easier to substitute in this equation, and therefore the equation gives you the value of y as negative 1. Therefore the point of intersection of these two lines is minus 2 comma minus 1, and the solution is x is equal to minus 2 and y equal to minus 1. So the basic idea is get the expression of y from the first equation, substitute in the place of y in the second equation, simplify them into single x equation, substitute the value of x in one of the equations, look for the easier ones, and then find the value of y. That is the method here. There is also another method for the same type of equations. Let's say y equal to 2x plus 3. I'm using the same equation, but I'm going to show you another method for solving these two. So we have these two equations. The first method we substituted the y into the second equation, but I can also change the second equation in the form of y equal to mx plus c. So this becomes minus 3y. I'm going to take y as my subject. So I'm going to retain my y on the left hand side and take all the other terms to the right hand side. Therefore y becomes, if I isolate y becomes 2 over 3x plus 1 over 3, and this is of the form mx plus c. Therefore I am going to take this as my new equation number 2. I can call this as equation number 3 for simplicity's sake, because I don't want to confuse with two equations. So now I'm going to solve equation 1 and 3. So if you collect them together and write them, you can see that both the equations are of the form mx plus c, and this is what we did in the first question. So in this case we are going to say, we are going to substitute the expression from the first equation into the y of the second equation. Therefore this becomes 2x plus 3 equal to 2 over 3x plus 1 over 3, and collecting all the like terms to one side and keeping the numbers to another side, we can see that you get the same value of x is equal to minus 2. And again, choose one of the equations. Obviously you won't choose 3 because it's more complicated with fractions. It's easier to choose number 1. So y equal to 2x plus 3, and I'm substituting the value of x as minus 2 in this. Therefore I get the same value as y. So y equal to minus 1 is the answer here. Therefore either way you can solve for this type of simultaneous equation, where one is in the form of mx plus c and the other is in the form of ax plus by plus c equal to 0. Now what happens if both the equations are in the form ax plus by plus c equal to 0? So we have here two equations as an example. It's very simple. Just change one of the equations in the form of y equal to mx plus c and substitute in the other equation. So whichever equation you want to change, you can choose. So let me choose equation 1, and I'm going to change this to y equal to mx plus c. So I'm going to retain the y part on the left hand side and take the remaining part to the other side, which means I get y as 3 over 2x plus 1 over 2. So this is new equation 1. Now I'm supposed to be substituting the value of y, the expression for y, into the y of the second equation, and therefore the second equation becomes 2x plus 4 times 3 over 2x plus half minus 3 equal to 0. So just simplify this. 2x plus 6x plus 2 minus 3 equal to 0, opening the brackets, and you get 8x minus 1 equal to 0, and this gives you x is equal to 1 over 8. It's the same method. The thing is, you are going to change one of the equations in the form of y equal to mx plus c and substitute into the second equation. So now you can easily find what is y. In this case, instead of using these two equations, it's easier to use this because it directly gives you the value of y if you substitute the value of x, right? So it is easier to use this equation to find the value of y, and this becomes 3 plus 8 over 16, which is 11 over 16, and the y value is 11 over 16 in this case. So x is equal to 1 over 8 and y equal to 11 over 16 is the solution for these two simultaneous equations. And now you know how to solve simultaneous equations using the method called substitution method. So this is the method we have done now. In the next video, you will be taken to a method called elimination method.
How to solve simultaneous equations using elimination method.
The steps involved in this method are: the first one is you have to choose the right variable to eliminate. For that, you can either choose x or y. You have to look into the coefficients of both x and y in both the equations given, and you will have more details in a little bit while. Now, once you have chosen the particular variable to eliminate it accordingly. Find the value of the remaining variable. The variable that you have eliminated would have gone off the equations. Now you will be left over with the remaining variable, and you are supposed to find the value of this remaining variable. And once you have found this value, choose one of the given equations, go back to the given equations, choose any one of them, substitute this value that you have just found into this remaining variable, and then find the value of the original eliminated variable. Once you have done with finding both the values of x and y, go back to the given equation, substitute them, and verify whether your answers are right or wrong. How do we choose the correct variable, x or y? For choosing the correct variable, you should look into the coefficients of either x or y. So coefficients means the numbers that are attached to the terms x or y. So there are 4 types of equations that you will be having under this category, and in that you have 3 main categories. The first category is that both the numbers, that is both the coefficients of either x or y, they are the same numbers with same sign. In this case, if you can see, the y term has the same coefficient, plus 2, same number, same sign. Whereas if you go to the next category, both are same numbers, but they are of opposite signs, which means if you check the y term here, you have the numbers are the same, the coefficients numbers are the same, 2 and 2, but the signs are different, plus and minus. So this is the second category of simultaneous equations you will have under elimination method. The third category is both of them are different numbers, that is both, if you are choosing one of the variables x or y, you will have the coefficients of x are different and coefficient of y is also different. So in this case, there are 2 more categories. The first one is a multiple of the other, which means if you can see here, 2x and 6x. 6 is a multiple of 2. So whereas in y it is not so. In this case, x will be the term that I will be eliminating. That will be the variable that I will choose to eliminate, because it comes under this category. One of the variables, one of the coefficients of one of the variables is a multiple of the other, which is if I'm choosing x, the coefficient of x here is 6 and x here is 2. 6 is a multiple of 2. So this comes under this category. I will choose to eliminate x in this particular example. The next category is there is no relation with any of the terms or any of the coefficients. So if you check x terms 2, 1, 3, there is no relation. If you check the y term 3 and 4, there is no relation. In this case, either one of them had some relation or the other, whereas in this case there is no such relation at all. So we will be solving all these 4 more types of equations in the next few minutes. Let's consider the first case. X plus 2y equal to 5 and 3x plus 2y equal to 7. We don't at the moment concentrate on this part of the equation, but we will see only this part of the equation. And we can see that x and x, there is no much relationship. But if you move on to the y term, we have plus 2, which comes under the first category that we saw. So they are of same numbers and same sign. So if I have plus 2 and plus 2, and if I want to get rid of this plus 2, that is if I want to get a 0 out of this, what would I do? I would actually subtract them. So plus 2 minus plus 2 would give me 0. So when they are of same sign, subtraction would be the best option to get 0 out of them. So I will subtract these two equations. First equation, I will call this as equation 1 and I will call this as equation 2. So I am going to subtract equation 1 minus equation 2. Which means term by term I should subtract. So x minus 3x. So I will subtract minus 3x, which will give me minus 2x. And 2y minus plus 2y, which will give me, cancellation of these two will give me 0 here. And then 5, I should be very careful that when I am subtracting, I should subtract both the sides of the equation. So I should subtract x to x, y to y and constant to constant. So 5 minus 7 would give me minus 2. So the new equation I've got is minus 2x plus 0 equal to minus 2. So I don't need to write this 0. So minus 2x is equal to minus 2. Therefore x is equal to 1. So when you go back to the steps involved, once you found the value of the remaining variable, which is in this case we have eliminated y. X is the remaining variable. Therefore, we found the value of the remaining variable, which is x, which is equal to 1. Now you go back to the given equations, choose one of them. Probably I will choose this equation because it doesn't have any coefficient with x. So it's simple for me to substitute. So I will choose the first equation. And then I will substitute x is equal to 1 in this equation, which becomes 1 plus 2y equal to 5. Now I can find the value of y very easily, equal to 4, y is equal to 2. So y equal to 2 is the value for y now. X is equal to 1 is the x value. Now we have x is equal to 1 and y equal to 2. Go back to the equations to verify. The first equation will be 1 plus 2 times 2, which is 5, and this is correct. Second equation is 3 times 1 plus 2 times 2, which is equal to 7 and which is given on the right hand side of this equation, which is also correct. So verification is also done. In this case, when the coefficients of one of the variables are same with same sign, you need to subtract the two equations. That's the catch of this particular example. Now going to the second example, where you have the coefficient of y as the same number, but their signs are different. So if I have plus 2 and minus 2, and if I want to get 0 out of them, I just need to add those two. So plus 2 added to minus 2 will give me 0. So since the signs are different, I will just add these two equations. So 3x plus x is 4x. Plus 2y plus minus 2y cancels. Therefore there is no y here. And then I am adding 4 plus 3, which is 7. Be careful when there are negative signs here. You are adding. If it had negative sign, you have to subtract them. So whatever sign here, you are just adding them. 4x is equal to 7 is what you are getting now. Therefore x is equal to 7 over 4 is the value of the remaining variable. Now go back to one of these equations and substitute. Which one would you consider? Considering you are going to substitute for x. So 3x is a more complicated job than for substituting in x, right? Therefore, I will take the second equation to substitute. X minus 2y equal to 3 is the equation that I will substitute. In this case, 7 over 4 minus 2y equal to 3. So minus 2y equal to 3 minus 7 over 4, which is 5 over 4. Therefore, minus 2y. Therefore, y equal to minus 5 over 8. Now you got these two values. You can just substitute in each of them and verify for the last step. So when you have opposite signs, the second category, the same number but opposite signs with any x or y, Now you have to add the two equations. So the equations are going to be added in the second category when the coefficients of the variable are same numbers but opposite signs. Going to the next option, we have, they are all different numbers, but the condition here is, if you look into the x variable, the second equation has a coefficient which is the multiple of the coefficient of the first equation. So 2 and 6. Now all that you have to do is make them one of the first two conditions, that is same variable condition, either it is same sign or opposite sign condition. So it will go back to these two categories. How can I make them into the same number? So I can change this 2 to 6 by multiplying by 3. So 2 becomes 6 if I multiply by 3. And if I multiply 2 by 3, I should multiply everything by 3. That's all I will do now. So equation 1 is going to be 3 times equation 1. I'm going to multiply equation 1 by 3 so that I'll get the same value for x coefficient with the second equation. So I'll get 6x plus 9y. Be careful to multiply the whole equation by 3. Each and every term in the equation 1 should be multiplied by the number that you are supposed to be multiplying here. Now rewrite the second equation as it is, because that's what we are aiming for. Now we have come to the first category of the equations where you have same numbers and same sign. So same number, same sign is subtraction. So you need to subtract these two equations. So if you are subtracting, you need to subtract term by term. So once you subtract, this goes off. 6x minus 6x, 9 minus 4 is 5y, and 15 minus 7 is 8. Therefore this gives you y equals 8 over 5 as value of y. Now going backwards, you can now substitute this y into the original equations. No need to use this equation anymore because it has more bigger coefficients. So let's go back to the original equation, and you can choose any of the equations. So I'm choosing the first one, and I'm going to substitute 8 over 5 for y in this, and then find x. So I will have x is equal to 1 over 10. So these are the two values for x and y for this particular question. You can again go back and check, verify them into the equation, substitute in the equations and verify them for both the equations. So when they are different numbers but they are multiples of, one is a multiple of the other, then multiply one of the equations to get the second number and match the numbers, match the coefficients and proceed. Even if you had a negative sign here, that's fine. You could have multiplied by 3 and you would have got minus 6x here, which will be same sign opposite, same number opposite sign. Then you would have, instead of subtraction, you would have added the equations. So that's all it is. Just the idea is multiply the number, the smaller number, to get the bigger number and match the second equation either in this form or in this form. Now none of them are related to each other, like there is no relation with x coefficient nor with y coefficient. So how will you do this? So the best method is again same number. You have to bring them to same number, either sign is the same sign or opposite sign. So that's okay. Either way, sign is not a problem because we can go back to the first two categories and then use the same method to find the values of x and y. But the idea is we need the same coefficients first, same numbers for coefficients in the first stage. So I will make this, I can concentrate either on x or y, that's okay. I want to make 2 and 3 to be the same number. So the best option is I'll multiply the 2 by 3 and 3 by 2 if I'm choosing x. If I'm choosing y, I will multiply the 3 by 4 and 4 by 3 so that both of them become 12. So, and then I can start eliminating y. Whichever you want to choose, you can choose in this category, but I'm going to choose x here. So I will multiply this by 3 and this by 2. When I'm multiplying this 2 by 3, that doesn't balance the equation. Therefore, I should multiply the whole equation by 2 and the whole equation, the first equation by 3 and the second equation by 2. So 3 times first equation will give me 6x plus 9y, be careful, equal to 15. Usually people forget to multiply the right hand side, so that it's always better you put the bracket like this. The second one is 2 times the equation 2, which would give me 6x plus 8y equal to 14. Now the new equations are, this is maybe I can call this as 3 and 4. These are the two equations I'm going to solve now. In this comes under this category, same sign, same number category, because 6x and 6x are there. So I need to subtract. So I need to subtract these two equations. So equation 3 minus equation 4. So if I subtract, I'll subtract 6x minus 6x, it goes off. 9y minus 8y will be 1y. And then 15 minus 14 will be 1. Therefore, y equal to 1 is the answer for y. Again, this next step is go back to the given equation. You don't have to do these two equations because it has bigger coefficients. So it will be much more difficult. Since it is 1, it might be easier, but it's better to go back to the equations which will have a lower coefficients. So let's go back to the original equation. 2x plus 3y equal to 5 and y equal to 1 is what I'm going to substitute, and then I'm going to find the value of x. So in this case, x is equal to 1 as well. So x is equal to 1, y equal to 1 is the answer. If you substitute x equal to 1 here and y equal to 1 here, you know that 2 plus 3 is 5, x equal to 1, y equal to 1, 4 plus 3 is 7. Therefore, the answers are correct. This is how you will verify the answers, putting them into the original equations. And that's all it is. All that you need to do is get every equation back to the first two types, and then you can solve them either by adding them or subtracting them. I hope you understood and you enjoyed this.
This is a video on tips and tricks. In this video, you will find a shortcut method to find the roots for quadratic equations that can be factorized. Consider this equation and let's solve this using factorization method. First, you will find the product and sum from the quadratic equation. The product is multiplication of these two numbers, which gives you 6, and the sum is the number in the middle, which is 5. And you will find two numbers which on multiplication will give you 6 and on addition will give you 5. So the numbers are 3 and 2 in this case, which satisfy both the conditions. 3 multiplied by 2 gives you 6 and 3 plus 2 gives you 5. And you will split the middle term into 3x plus 2x. The 5x which is in the middle will be split into 3x plus 2x, and the equation will be written like this. And then you will simplify the equation, factorize it, and solve individually as x is equal to -1 or x is equal to -2/3. And this is the way you do when you are asked to solve this equation by factorization method. Okay, let's see something special from here. When you divide by 3 by -3, you get -1, which is one of the roots. And if you divide this 2 by -3, you get -2/3, which is the other root. So where is this -3 coming from that we are dividing here? You can see that the leading coefficient of the equation is 3, and therefore the -3 is nothing but -a, where a is the leading coefficient. Therefore, we are dividing by the opposite sign of the leading coefficient to get the roots. So let's consider another example and see if it works. This is the equation. So product and sum. Product will be -10 and sum will be -9. So choosing the number accordingly, you will have -10 and +1, which on multiplication will give you -10 and addition will give you -9. Therefore, the middle term is split into -10x plus x, and simplifying further, you will get these two factors. Solving those two factors individually, you will get x is equal to 2 or x is equal to -1/5, which will be the roots of the given equation. The leading coefficient here is 5. Therefore, we have to divide each of the numbers that we chose by -5. So, -10 divided by -5 will give you 2, which is one of the roots. And +1 divided by -5 will give you -1/5, which is the other root. So, actually this works. Once you find the numbers for product and sum, you just need to divide those two numbers by the negative of the leading coefficient, and then you will get the roots. Let's prove this in general. Ax square plus bx plus c equal to 0 is a general form of quadratic equation. And the product is ac and the sum is b. So you will find two numbers, m and n say. So that m times n should give you AC and m plus n will give you b. That is the way we proceed, and you will split the middle term bx into mx plus nx like this. Now let us divide this equation by the leading coefficient a. Now we have AC equal to mn because m times n gives you AC, and therefore C is equal to mn over A. That is going to be substituted in the place of C in the equation, which gives me the constant as mn over A square. Rewriting this as x square minus of minus m plus n over A, I am just changing the plus into 2 minus here, and the remaining things are left as it is. Now I am going to split this further like this. Minus of m plus n over A can be written as minus m over A plus minus n over A, and mn over A square can be written as minus m over A multiplied by minus n over A. Why I am writing this? Because we know that x square minus alpha plus beta x plus alpha beta equal to 0 is the quadratic equation when alpha and beta are the roots of the equation. So you can now compare the equation in green with the last equation that we just did, in which case alpha is negative m over A and beta is negative n over A. Therefore, alpha is m over negative A and beta is n over negative A, which means the m and n are the numbers that we found for product and sum, and if we divide them by negative A, we get alpha and beta, which are the roots of the equation. So it does work for any general equation ax square plus bx plus c. So let's continue and check this out. We have this equation, the product is 14 and the sum is negative 15. So you will choose the numbers as negative 14 and negative 1. And now by the proof that we just did, we have to divide this by negative of the leading coefficient, which is 7. Therefore, dividing it by negative 7, each of those numbers, we should be getting the roots. The roots should be 2 and 1 over 7. So there is no need to factorize anymore. You just have to find the numbers for product and sum, divide by the negative of the leading coefficient, and you will get the roots. Let's consider another example with negative leading coefficient. Here in this case, negative 4 is A. The product will be minus 20 and the sum would be plus 1. The numbers you would choose here are plus 5 and negative 4. Now the leading coefficient is negative 4, so dividing by negative A means dividing by negative of negative 4, which is positive 4. Divide the numbers that we found by positive 4 and we should be getting the roots. Therefore the roots are 5 over 4 and negative 1. So you have just learned how to find the roots of a quadratic equation when they are factorizable. So you just need to find the numbers for product and sum, divide each of them by the negative of the leading coefficients, and there you get the roots. In today's A Concept A Day, we will be solving cubic equations with real roots. A cubic equation is generally expressed as ax cube plus bx square plus cx plus d equal to 0, where a, b, c, d are real numbers. In order to solve this equation, the first step is to convert this into linear factors x minus p, x minus q and x minus r equal to 0, and then solving each of these linear factors, x minus p equal to 0, x minus q equal to 0 and x minus r equal to 0. You will get the roots as x is equal to p, x is equal to q and x is equal to r. These are the three values of the roots for the given cubic equation. In order to convert the equation into three linear factors, we use a theorem called factor theorem, which states if x minus a is a factor of a polynomial p of x, then p of a equal to 0, which means if you substitute the x value as a in the equation, you will get the value as 0. Therefore, p of a equal to 0 gives you x minus a is a factor. This is what we are going to use to factorize the cubic equation. So let's consider an example. 2x cubed plus 5x square minus 4x minus 3 equal to 0. So we will get the first factor by using something called trial and error method, which means we will try to substitute the value of x from negative 1, positive 1, negative 2, positive 2 and so on until we get the value of the equation as 0.
For example, let's start with x is equal to -1 for this equation, which does not give you a 0 value, whereas x is equal to 1 gives you a 0 value for the equation. Therefore, x minus 1 is a factor using factor theorem, which means x is equal to 1 is a root. Therefore, the first factor that we have found is x minus 1 using the factor theorem. Now we need to find the next two linear factors. In order to find the next two linear factors, we will divide the given equation by x minus 1, which means 2x cubed plus 5x squared minus 4x minus 3 can be expressed as x minus 1 multiplied by a quadratic. If you have not learned how to divide polynomials, follow the link given in the description below. Now we need to factorize the quadratic here, which is 2x squared plus 7x plus 3. And if you factorize it in the normal way, again, if you have not learned quadratic factorization, there is a link in the description below which you can follow and learn how to factorize quadratic equations. Now this equation can be factorized into 2x plus 1 and x plus 3. Now the cubic equation can be written into three linear factors, x minus 1, 2x plus 1 and x plus 3. Solving each of them, you will get three different roots. X is equal to 1, x is equal to -12 and x is equal to -3. And these are the three roots for the given equation.
This is complex numbers part 3, and this video is about roots of polynomials. Now, you need to have a knowledge about solving quadratic, cubic and quartic before you watch this video. So if you have not learned about how to solve quadratic, cubic or even quartic, it is suggested that you learn that and then come to this video. Okay, the first thing is solving quadratic. So let me give you two quadratic functions, or equations rather, and then you can solve these two. Pause the video, try to solve them, and then come back to see if your answer is correct. Here are the answers for this. Hope you were able to get these answers when you solved them. Now, the answers here are -6 plus or minus square root of -4 over 2 for the first one, and for the second one -1 plus or minus square root of -3 over 2, and which is here. Now let's start simplifying this, and you can see very well that this part, the discriminant part, is negative. Therefore we are going to have complex numbers as its answer. So how will you simplify square root of -4? So this can be written as square root of 4 times square root of -1, and square root of 4 is 2 and square root of -1 is I. Therefore square root of -4 is actually 2I. So this can be written as -6 plus or minus 2I over 2. Or in short, if you simplify this further, this is -3 plus or minus I. Actually, this is -3 plus I is one answer and -3 minus I is another one. And you can see that they are conjugate of each other. So A plus BI and A minus BI are called conjugates. If you have watched my previous video, you know what conjugate is. So conjugate is changing the imaginary part. Plus B becomes minus B, but the A, the real part, remains as it is. How do you simplify this? -1 plus or minus square root of -3. I can write square root of -3 as square root of 3 times square root of -1, which is I. Therefore, square root of -3 is square root of 3I. So this becomes -1 plus root 3I over 2, or -1 minus root 3I over 2. And you can split this and write it into proper complex form, which is -12 plus root 3 over 2I, which is A plus IB, or -12 minus root 3 over 2I. So you can see again that this and this are conjugate of each other by changing its imaginary parts. So let's move further and solve a little more of quadratic equations. Now try to solve them by pausing the video and check your answers here. This is the answer. And in this case you have -6 plus or minus square root of -24 over 6. -24 can be simplified further as square root of maybe -6 times 4, divided by 6, or you can even use 8 times 3, but 8 is, they are not going to help us to remove from the bracket, from the square root. Therefore this is minus 6 plus or minus 2 root minus 6 over 6, and this can be written using complex number, imaginary number, square root of 6 plus or minus 2 square root of 6 I over 6. You can either simplify this as minus 1 plus or minus 2 over square root of 6I if you are comfortable, or you can leave the answer here, which means that you are still getting conjugate pairs as its answer. So when do you actually get conjugate pairs? You get conjugate pairs when the coefficients of the equation are real numbers. When you have imaginary coefficients, then this will not be a case. You cannot get a plus bi and a minus bi as the roots. They may be completely different. But you get conjugate roots only if all the coefficients are real. If I have something like 3i x square plus 4x minus 4I equal to 0, something like this, and you can see that the coefficients have I in them, which are complex numbers. Therefore in this case the coefficients are complex, and it doesn't give you roots with conjugate pairs. So roots with conjugate pairs will occur only when you have equations with real coefficients. And in this case, you cannot simplify root of 51. Therefore, you can just write this as square root of 51I over 2 plus or minus, and therefore they are conjugate to each other, and you can still see that the coefficients are real numbers. It could be positive, negative, decimal, anything but real numbers, not complex. Let's move on to cubic. Z cube minus z square minus z equal to 15, and in order to solve cubic you need to find the first real root using trial and error. And there is one more, cubic z cube plus 6z equal to 20, and try to solve them before you can see the answer on the video here. And these are the answers. So z equal to 3 is the first real root, and you should have noticed that the equation starts now using z as its variable, not x, because when we are dealing with complex roots, usually the equations are in z, not in x anymore. So z equal to 3 is a root, z minus 3 is a factor, so divide the equation by z minus 3, and then you will get a quadratic, and solving the quadratic as you would, and in this case you cannot factorize them, therefore you solve by using the quadratic formula, and you get minus 2 plus or minus square root of minus 16 over 2. In simpler form it will be 4i over 2, and you can still simplify this minus 1 plus or minus 2i, and still you can see they are conjugate pairs because the coefficients are real. Coming to the next question, I hope you would have solved this using the first trial and error method to get the first real root, which is 2, and in this case the roots here, complex roots here, can be written as minus 1 plus or minus 3i if you simplify this further. Okay, and the roots for this equation, the cubic equations, are 3, minus 1 plus 2i, and minus 1 minus 2i. You should not forget the first 3, which was found by using the trial and error method. And in this case the 3 roots are 2, which is a real root, and minus 1 plus 3i, and minus 1 minus 3i, which are 2 complex conjugate roots. So how does this affect the graphs? What about quadratic? Quadratic has 2 roots, z minus a, z minus b, and again you can notice that I've started using z because there is a possibility of having complex roots. So when both a and b are real roots, then the quadratic would look like this, either up or down. So I'm just using one part. So basically speaking, you'll have 2 roots on the x-axis. The graph cuts the x-axis at 2 points when a and b are real roots. And if a is equal to b and still they are real roots, then you know that it touches the x-axis because you have equal roots. But when a and b are complex roots, you know that complex roots occur when the discriminant is less than 0, and when we were doing quadratics we said there are no solutions. But now we have produce the solution. This solution is called complex solution, but we cannot represent them on a real number, a real coordinate axis. But so you will have the complex, the quadratic curve to be like this, not cutting any of the x values on the x-axis. Therefore, it's either above or below the x-axis, and it doesn't cross or touch the x-axis when the roots are complex. So this can be applied to cubic as well. So cubic, you have three roots. In these three roots, one root has to be real. Remember that this was the real root we found by using trial and error method. And the other two roots could either be complex or both are real. So if one is complex, the other one is complex. So if one is complex, then both the roots should be complex. Okay, so there are only two possibilities where all of them are real, or one real and two complex. You can't have two real and one complex, because one complex number cannot occur separately. It has to be going on with its conjugate pair. So it's always two at a time when the coefficients are real. Therefore, if you have all three real numbers, you know that a cubic looks like this, where it cuts the x-axis at three different points. But when you have one real root, then the cubic crosses the x-axis at one point, but later it doesn't cross, but it goes like this. So when b and c are complex numbers, then the curve actually crosses the x-axis only once. The same thing applies for quartic, but quartic is more interesting because you have four roots, and a general quartic will look like this or will look like this. Okay, a W curve. So you can have possibilities of here is A, B, C, D all real, or if you have you can see this as two quadratic, right? So the same thing applies. So you can have two real from the first quadratic and two complex from the second quadratic, or you can have all of them complex. Okay, as I said, you cannot have one real and three complex. I cannot have like A real and B, C, D complex, because I need to have complex roots in pairs. So if this was the case, A, B, C, D real, then the curve would look like this, where it crosses the x-axis four times. And it could be the other way around as well, depending upon the coefficient of z power 4. Now, two real and two complex. Let's move on to two real and two complex. So in this case, it cuts the x-axis twice, like this. And then furthermore, there are no crossing the x-axis, so the quartic equation would look, the function would look like this. It doesn't cross the x-axis anymore. And obviously when all four are complex number, it doesn't cross the x-axis at all, so it should either look like this or look like this, above or below the x-axis. Hope this is clear here. Now let's move on to the next. How to get the polynomials using roots. That is, you are given the roots. How do you get the quadratic, cubic, or quartic? For quadratic, both real roots, you need to have both the roots given. For example, you can find the quadratic equation whose roots are 2 and 3. In this case, you can easily find the quadratic like x minus 2 times x plus 3. That's easier. But if you have both are complex roots, that's the other option that quadratic can have, then you need to use this property. Complex roots of a polynomial with real roots, always they occur in conjugate pairs. So in this case, it's enough if you are given one complex root and you can find the other one like as its conjugate. Therefore the two roots are 2 plus 3i and 2 minus 3i. So I will start using z because we have complex roots. So the first linear pair would be 2 plus 3i, right? And then the other factor would be z times 2 minus 3i. And you need to multiply these two factors. It's easy to multiply. Like you can expand this, z minus 2 minus 3i, the first one. Open the bracket for the complex number, z minus 2 plus 3i. Once you open the bracket, then you can identify that it's of the form a minus b and a plus b, which gives you a, this is a square minus b square. And you should remember that always I square is minus 1. Therefore, this is z minus 2 the whole square minus 3 times minus 1, which is 3 square, which is 9 times minus 1. Therefore, it's plus 9. And if you simplify this further, that's z square minus 4z plus 4 plus 9. And this becomes z square minus 4z plus 13. So this is the quadratic equation with these two roots, complex roots. You can try them out using quadratic formula and you'll be coming to this solution. Okay, hope you understood that. Especially this part is more complicated. You cannot use a minus b, a plus b in this area. You need to simplify this to this level and then you can use a minus b, a plus b formula here. Next, what if it's a cubic? You are supposed to find a cubic. So what are the characteristics of cubic? Cubic can have one real root, two complex roots, or all three real roots. Okay. So if all three are real roots, you need to have all these three real roots in order to find them, like this: 1, minus 3, and minus 2 and 3. So your cubic would look like this, right? And you can simplify this. The other case is, if cubic has one real, two complex, it's enough to know the real root and one complex root like this. So you have the real root 4, which gives me z minus 4. And then this will give me the other root is 3 plus 2i. So I can get them 3 minus z minus 3 minus 2i and z minus 3 plus 2i. And as I explained before, for quadratic, you can simplify these two into quadratic and then multiply that quadratic with z minus 4 to get the cubic. Moving on to quartic. In quartic, you can have different options: all 4 real roots, 2 real and 2 complex, all 4 complex. If all 4 are real roots, of course you need to be given all the 4 real roots so that you can make the equation like this with linear factors. And this is easy, you would have done this before. It has 2 real roots and 2 complex roots. What do we need? You need both the real roots, and it's enough if you have one complex root so that you can get the other complex root. Now you have 4, 1, 2, 3, 4, and you can use this technique as z minus 3 times z minus z plus 5 in this case, and these two can be simplified to a quadratic, and the next part can be simplified together as another quadratic. Then you need to multiply both the quadratics together to get the quartic. Okay. When 4 of them are complex roots, again it's enough if you know 2 of them. Like this will give you the second 3 plus 4i, the conjugate of this, and the conjugate of this. Now you have 4 roots and you can use them to simplify, like put the conjugate roots together so that you can simplify as I explained to you on quadratic. And then so I'm writing the conjugate factors together, the factors with conjugate roots together. So these two together will be forming a minus ba plus b form, and then these two together will be forming a minus ba plus b form, and then you'll have 2 quadratic. Then you can multiply the quadratic to make the quartic. Hope this is clear. Hope you enjoyed this video. Again, as I said, practice more makes you more perfect. So practice more and more and more problems. Then you'll understand what is behind the scenes of these wonderful concept. Bye bye. See you in the next video.
If you like my videos, press the like button and do not forget to share it with your friends. Please subscribe to the YouTube channel to get the latest updates whenever I upload a video. Don't forget to register in the website ganitika.com to enjoy more mathematics. Thanks and bye bye.